111 is where your title page is going to glue in. You can go ahead and do that now. Okay, on your table of contents, this is Unit 5, and the unit title is Square Root and Inverse Functions. On page 112 and 113, we're going to talk about the parts of a radical. And on page 114, I'm going to show you how to convert between radical form and rational exponent form. Again, if you've not done so already, this page moves in on 111. I kind of did today as a short mini day, because this will be the last day that you will have a chance to work on your projects in class. Your projects are due on Friday. Again, every day that they are late, they are 10% off, so please make sure you are done. You've had 3 weeks to work on them. There you go. Okay, before we get started, can anybody tell me what a radical is?
I heard it, but I can't remember.
Got all of your note pages. Can you decipher from your note pages what a radical is and what we're going to talk about in this unit? Or Maybe from the title of the unit. What is a radical? What? Square root. Okay, so radicals are your square roots, your cubed roots, the fourth roots. Anything to do with that square root symbol. Okay, so we're going to start with this page. It's going to get cut in half. One goes on 112, one goes on 113. So please cut this in half at this time and glue it in on those 2 pages. If you would like, the other page glues in on 114. You can go ahead and get that glued in so it's already there, and we don't have to worry about that either.
Yeah, welcome back, man.
Everything you see on this page is a radical. So this blank down here is radical. Everything above it is radical. Each radical has 3 different parts. First off, you must have a radical symbol for it to be a radical. Okay. Underneath your symbol, you will always have a number or a number in letters. So something like this. This part of your radical is called the radicand. Okay, this is the number or the variables that we're taking the root of. So, for instance, if I give you the number 25, what is the square root of 25? 5. 5 times 5 is 25. Okay, so your radicand is what you're taking the root of. We also have something called the index, which is this little tiny number that fits in like the little crook of the radical symbol. And again, this is called your index. This is how many times you're taking the root of. So a 3 means we're taking the cubed root. So instead of having like 5 times 5 is 25, because we're taking the square root, so that's why you have 2 5s, the cubed root would be something like the cubed root of 8. 2 times 2 is 4, times 2 is 8. So the cubed root of 8 is 2. You need to have 3 numbers, 3 of the same numbers that multiply together to give you the cubed root of your radicand. So something like the cubed root of 27 is 3. 3 times 3 is 9. Times 3 is 27. So cubed root, I'm taking 3 times 3 times 3. I'm taking it 3 times. If for some reason we don't have a number written here for your index, the index is automatically a 2. So if there is no number written there for an index, it's automatically the square root. Everything else will have a different numbered index written there for you. Questions so far? Okay. On the next page, all we're going to do is we're going to identify what your index is, and we're going to identify what your radicand is. So, on this page, this first example, what is my index?
2.
2. There's nothing written there. It's a 2. That is the square root, which means it's an automatic 2. What is your radicand? What are we taking the square root of?
24.
24. Okay, the next one. What is my index?
4.
4. And what is my radicand?
128
128.
and
And to the 8th. Okay, it's everything underneath that symbol, not just your numbers. Go ahead and take a couple minutes and do the rest of these examples, and we'll go over them. the next one. What is my index here?
3.
3, and my radicand is
16 XY.
16xy. Index
6.
6, radicand
44, 8, 2x to the 7th, and y to the 7th.
my next one. Index
2.
radicand.
X to the 2nd.
Okay. Index
3.
radicand. Index
2.
radicand.
12.
Index
2.
radicand.
K.
Index
3.
radicand.
-162.
Just so you're aware, you should have learned this before, because I know you've done a little bit with square roots before. You can only take an odd root of a negative number. Okay, so you would never be able to take the square root of -162. Because -5 times -5 would always be a +25. So you can never ever take the square root of a negative number or the fourth root of a negative number. Your index always has to be odd if we're taking the root of a negative. Okay, just a tidbit of information. All right, one more page, and then I've got an around the room activity we're gonna do.
Here you go with the room activity.
Converting between radical form and rational exponent form. So any radical, we can get rid of that radical symbol and turn it into an exponent. Okay, so let's say we had something like the cubed root of x to the 4th power. Okay. You always keep the 4. The 4 always stays in the top. The cubed root. Instead of typing into your calculator the cubed root of x to the 4th, you can always type in x raised to the 4/3. Okay, so if I had something like the square root of x, that would be x raised to the, right now, what is x raised to underneath my symbol? If there's nothing written there.
2.
Go back to what,
Oh, I know.
if there's nothing written in front of my x for a coefficient, what is always written there?
1.
1. Same thing with your exponent. If there is no exponent there, that means it's automatically raised to the 1. What's my index of a square root? 2. So this would be x raised to the 1/2. Okay. If I had something like the 6th root of x to the 3rd, this would be x to the
3rd. 1/3.
3/6. Exponent goes on top, index goes on the bottom. What's 3/6 reduced down to? 1/2. So this is truly x to the 1/2. Okay, let's say we have, let's do 13 roots of x to the 7th. 7/13. It's always exponent over index. Okay, these things are equivalent. They're equal to each other. So I can put into my calculator the square root of x, or I could put into my calculator x raised to the 1/2 power. I can put into my calculator 6 roots of x to the 3rd, or plug in my calculator x raised to the 3/6, or x raised to the 1/2. You're gonna have to convert between the two. Okay. Question. This is all the new information I have for you today. We're gonna do an around the room activity. You do have homework tonight, but I want to give you time to work on your project. That way, if you have questions, you may ask me. Okay, any questions on the lesson today?
You just doing this.